Hello everyone, welcome to my YouTube channel. So in the first part of introduction to statistics, we went through what statistics is. Let me just scroll through what is business statistics, what is statistics, and then statistics, two divisions of statistics, what is population, what is sample, census. So all these things we have seen. So in this video, let us talk about what are parameters. So parameters are mainly concerned when we use population instead of a sample, a descriptive measure. So parameters are descriptive measures of the population. Now, what can be the parameters? It can be the population mean denoted by mu, population variance, sigma square, and population standard deviation, that is the square root of variance denoted by sigma. So we will see all these things later on in detail. So just to start with, what are the things, introductory things we should know that we are just going through. So a descriptive measure of a sample is called a statistic. So a descriptive measure of a sample is called statistic. So you can find this difference, what is a parameter and what is a statistic. The same this mean, when this becomes sample mean denoted by x bar, then it becomes a statistic. When you consider the same measurement for a sample, then sample variance is square, sample standard variation, the square root of a square is. So population mu parameter, you can refer to this figure. So where it is described. So calculate x bar to estimate mu. So when we are considering sample, we will calculate x bar and tell that that is the mu for the population. So here we select a random sample from the population. So that is the difference between parameters and statistics. So you should have a clear idea about what statistic is and what parameter is, when we call statistic, when we call parameter. So that's why this whole discussion we did about this slide. Next, a very important concept is the types of data. What are the different types of data? Broadly, data can be divided into two types, like qualitative and quantitative. So qualitative is also called as categorical data, and quantitative is described as discrete or continuous data. So now, what is a categorical data? It can be divided into nominal data, ordinal data, and this quantitative data, this can be divided into interval scaled data, ratio scaled data. So interval scaled data is called discrete data, and ratio scale data is called continuous data. So we will go into the details and see. So for example, categorical data is like, say in a column we have mentioned if it is a male or a female, or is it a cat or a dog, two classes, or we say it is there is something is present or absent, 0 or 1, true or false. So these are all examples of categorical data. And under that, again, we have nominal data and ordinal data. We will see what are these. And discrete data, broadly, you can understand that discrete data is something that is countable. you can count 1, 2, 3, 4 like that. For example, the number of stars in the sky. The number of stars can be infinite, but it can be counted 1, 2, 3, 4 like that. You can count. For example, number of students in a class. So that can be counted. Now in continuous data, what happens is in an interval, or that is a ratio. So the ratio should form some meaning. In continuous data, like height of the students in a class, the weight of the students in a class, these are all continuous data. We will go into the details. So just be in the video. First, we will discuss about the nominal level. Nominal level data, or simply you can call it nominal data. This is the lowest level of data measurement in the nominal level, used only to classify or categorize, like male, female, yes, no, 0, 1. Now here, chi-square statistics can be applied to nominal data. So this point is slightly advanced to discuss at this stage. So what is chi-square statistics, and why we are telling that chi-square statistics can be used for nominal data. So the purpose of writing this is that not many statistics can be applied to the nominal data. Out of other statistical parameters, we have chi-square statistics that can be applied to nominal data. Now, non-metric or qualitative. So this is non-metric or non-numeric, and this is called qualitative data. What are the examples? Employee identification number, sex, religion, ethnicity, geographical location, and place of birth. Now, which of the following employment classification best describes your area of work? Now, this is the question, and based on that, see, here we have written educator, construction worker, manufacturing worker, lawyer, doctor, other. So now this is an example of nominal data. Now we can represent educator with the numeric value 1, construction worker with the value 2, manufacturing worker with the value 3, and so on. But you should understand that representing this text with the help of a numeric value does not turn this data from nominal or from a qualitative data to a quantitative data. It is not converting the qualitative data to a quantitative data. It is just a representation. So even in this column, say one column is there where employment classifications are mentioned. There, instead of educator, construction worker, and these things, we are mentioning 1, 2, 3, 4, 5, 6. And in the legend, we are giving this description so that people understand what is 1, what is 2, and what is 3. Hope I have able to explain this concept. So even if we represent with a numeric value, so this is still a nominal data, a qualitative data. Next, ordinal level. So what is ordinal level? In the previous example of nominal data, here we have seen 1, 2, 3, 4, 5, 6. But there is no order in this data. We cannot say that educator comes first, then comes construction worker, then comes manufacturing worker. Like that, there is no ranking or there is no gradation among these numbers. Now, if we can select some data where is some gradation, that 1 means it is good, 2 means it is better, 3 means it is very good, like that, then we call it as ordinal data. So ordinal level measurement can be used to rank or order objects. So here if you see, this computer tutorial is not helpful, somewhat helpful, moderately helpful, very helpful, extremely helpful. And you can represent this text with these numbers 1, 2, 3, 4, 5 like this. Now we can say here there is a natural ranking. 1 is the lowest, that is not helpful. 2 is somewhat helpful, moderately helpful 3, very helpful 4. So there is a natural gradation. So then we call this as a ordinal level data. With ordinal data, the distances or spacing represented by consecutive numbers are not always equal. Now, if I say 2 minus 1, it does not mean anything. Somewhat helpful minus not helpful. The gap between these 2 and 1 might not be same as the gap between 2 and 3 or the gap between 3 and 4. The gaps are not equal, non-metric or qualitative. So ordinal data is also non-numeric and qualitative data. So these are the two things, or nominal data and ordinal data. Hope you are able to answer. If any doubts, you can just post a message to ask specific questions so that I can explain that. Then interval level. Now this interval level data measurement, distance between consecutive numbers have meaning and the data are always numerical. So for example, if I say there are, say, if I write like this, there are 10 pencils. Now then there are 20 pencils. There are 30 pencils. So these 10, 20, 30 are all numeric. So numeric data, and the difference between these 10 and 20 have some meaning, that there are 10 pencils more in 20 than in 10. There are 10 pencils more in 30 than in 20. So interval data has equal intervals, even if it is, say, 11. Say this is 11. So you can deduct one from the other and there will be an equal interval. Example, with Fahrenheit temperature numbers, the temperatures can be ranked and the amounts of heat between consecutive readings such as 20, 21, 22 are the same. So if you write like this whole number, so the difference between each, for example, here 12, here say I write 13. So the difference between each consecutive number is equal. With the interval level data, the 0 point is a matter of convention or convenience and not a natural or fixed 0 point. So here say 0 degree Fahrenheit, if I mention, that does not mean that there is no heat, because it is not an absolute scale. So 0 does not mean the absence of something here. So that is interval level data or discrete. simple thing you can understand is interval level is discrete data, discrete, countable. You can count the data. So this is another way of understanding this. Okay. So next, ratio level. Ratio data have the same properties as interval data, but ratio data have an absolute zero. Like in the Kelvin scale, if you see the temperature, there is an absolute zero where we define that temperature as the absence of heat. The ratio of two numbers is meaningful, or this you can also tell as continuous data, like height, weight. So it can be a fraction. Say you can compare, say Ram's weight is 25 kg. Shyam's weight is 30 kg. So ratio Ram by Shyam, if you take, is equal to 25 divided by 35. So you will get a decimal number, something. Now the notion of absolute zero means that zero is fixed, and the zero value in the data represents the absence of the characteristics being studied. So height, weight, time, volume, Kelvin temperature. So these are examples of ratio level data or continuous data. They are called metric data and sometimes referred to as quantitative data. So most of the things that we will be discussing are mostly related to ratio level data. So this is the highest level of data. Gradually, if you see, first is the nominal data, then the ordinal data, then the uh, what was the last one? Interval level data and the ratio level data. So as we study data analytics, artificial intelligence, machine learning, so these concepts are very basic that you should have in your mind so that whatever you learn in this field is meaningful. So that's why I have taken up statistics in the very beginning so that you understand this concept, and this is very interesting, and everywhere in machine learning and all you will be referring to these things. So that's why